Hello guys, I am Alimul Karim and today we're going to talk about database exam questions for conceptual layers. These are not for SQL exams, these are for conceptual layers which I ask in interview or it's my type of question. So if you are going to interviewed by me, be prepared for this. So here is an example of a question which is handwritten. So whenever I ask to design an entity diagram, it should be as simple as this. So you first draw a box and name your entity, and then another box if both have or these two have one-to-end relationship, then just have three lines there and one line here, and write one here and in here, which can be represented or can be said as one product can have multiple orders, something like that. So here I have an example question. Um, Design a product database where a product can be ordered multiple times and clients will be verified by their cell phone numbers, and employees and clients address should be kept in one table. A client can order one invoice which may have one or more orders, and one client can have more than one invoice. That's a condition. That's a very simple condition, and for based on that, we could have a diagram like this. So a product can have multiple details, order details, and invoice. Invoice can be ordered by one client can order multiple invoices, and one invoice could hold multiple of orders. That's simple. So, and the addresses, clients and employees addresses should be kept in another table for optimization purposes. And the cell phone number, it should be verified by your programming system. It shouldn't be designed here. So that's it. So how you can do it in computer. So if I'm taking your exam remotely, so how can you draw it? So let me show you an example with PowerPoint that how you can do it. Here is a PowerPoint where I have drawn all those. These are very simple to draw. You can draw it yourself or you could get this PowerPoint to draw those. So if you want to draw, let's say, one product, so product can have, one product can have multiple of, let's say, products. Sorry, order details. So order details. So you could use this and then put it just right there. You're just fine. So that's how you draw such designs. So if you take a look at invoice, how can I do it? So copy paste, name it invoice, and invoice have one to n. So n should be in front of invoice, and client, there should be client. So if you think that it's big, you could shorten up like this and something like this. Just put it down. That's it. So then one invoice can have multiple of orders. So one invoice can have multiple of orders. So that's simple. Something like this, which makes sense. Okay, so that's how you can design an entity diagram if a question is given to design an entity diagram. And there could be questions where I ask to design a database from the entity diagram where no properties are given. You have to think through what kind of properties there could be. So For this, I use SQL Server Management Studio. You could use Navigate as well, whatever fits you. But the concept is should be able to design database based on this concept and add some properties which should be meaningful to those entities. That's it. Here, create a new database. Exam one, let's say. Okay, so in the database, you will find that there is something called database diagrams. Say yes and create a new database diagram. So here, just say table new, and we have product. So a product should follow a convention, and I follow this convention, that whatever the table name is, plus your primary key should have an ID name. So the table name plus the ID should be your primary key field. In this case, we're assuming we have a small operating system, so we are giving the int as a primary key. But if you think that your sales is every day, let's say 1 million, so you shouldn't keep the primary key as int. You should consider big int or GUID. So if you GUID represent, or GUID is represented as unique identifier in database. So GUID represents that whatever value it generates, it shouldn't be same ever in the world, ever in the universe. So one unique identifier means one time the key is generated, it will never be same again between time and space. That's it. So if you have something million or billions every day selling, you should consider unique identifier. But other than that, you could go for int, or if you have bigger than that, you should consider big int. Because once you have an overflow in your database system, it is really very hard to change the data types. You can do it, but it's really very hard. So make sure you design based on the question given. I just put the primary key as it is, and since it's a number, I'm going to put that the property as identity. So you can do it by selecting the property. Inside here, you could say that identity true, and to make the primary key auto incremented. That's it. So a product could have a product name, and product name should be varchar, and product could have a product category, but product category could be multiple, and it shouldn't be characters in your table. So it should be a primary and foreign key relationship. And if you think about it, in most cases you should have less than 2 billion product categories. But if you have more than 2 billion product categories, you should go for big int. And if you ran out of big int, you should consider unique identifier. But for product category, it should be int. And if it is, let's say you have only 10 product categories, and on maybe on highest, if you pass 10 years, it could be 200 to 300. You should consider something called small int. You should consider a small int, which is smaller than int, which has a limit of 32,000. So if you have a product category which increments in 10 years only 100 to 200 or maybe 500, you should consider a small int. And if you have a product category which increments thousands every year, or maybe in 10 years, or maybe 2000 in 10 years, you should consider int, which have a 2 billion limit. So if you have a product category which increments by, let's say, 0.1 million per year, you should consider big int. So that should be the concept that we're talking about. So for our case, the product category should be very simple, and there is no product category in our design, but since a product should have a product category, so we're designing a product category table and relationship. Okay, so here, small int, and it should be primary key, and it could give it identity. That's it. And the category display. That's it. And whatever convention you follow, you should keep the same throughout the database system. If you follow your database primary key as ID, you should keep the all IDs or primary keys as ID. That's it. So I think this convention is better, which you can get the which primary key it is, and which is really very helpful when you just join those. Because whenever you see that ID, you'll understand that it's a primary foreign key relationship. You don't have to go through the relationship chain. It's very useful. I've seen that these conventions are helpful to many of the developers, and it really optimizes time issue and many things. Try this out. And a product could have a price. It could have different type of price, but for our reason, we're going to make very simple and just say the price. And let's say that we have a buying price, because as a product, we have to buy it first. A price, if you really think about it, if your product price range is between 0 to 32,000, you could go for a float, but float is not a good representation of a number. If you have a fraction and you want to have very precise point of numbers, float is not a good choice. So designers always tend to avoid float, but if you have a very mid-range number where you don't consider exceeding 32,000, or you don't have a very precise point of numbers, you could go for float. But if you don't, go for double or decimal maybe in this case. So in programming, you could go to double, but in database, you have to go for decimal. And in decimal, if you want precision point, how many precision points you want, you should put it here. Let's say I want 5 precision points, so I put 5 there. If you put 0, it will only consider it as a 18 digit of integer numbers. So make sure you put decimal points here so that your field acts as a fraction of points. So that's it. And none of those could be null, because product name should be there, buying price and selling price, let's say. So decimal, selling price, I'm choosing for 4. And in the display level, you could choose how many digits you want to show, but in the database, I'm keeping 4 decimal places, which is very convenient for me, and to have the very precise number of calculation in my software. So again, a product could be, let's say, okay, on the top of my head, I can't think anymore. Let's go to another topic, which is client. So a client, so you should keep your primary ID as table name and ID. So in this case, I really prefer that you shouldn't keep a primary key to varchar, because it's very costly. If you keep varchar, let's say 10, it's really outrun begin. So don't do that. Try to keep your primary keys int, bigint, or unified identifier or GUID. Don't try to keep it as varchar. It's very costly. It doesn't optimize. Database design matters, and physical database design really matters when you have millions of data. So you have to think through. For clients, if you're expecting 2 billion clients in your lifetime, you could go for int. But if that's not the case, maybe you're expecting more than 2 billions, you could go for begin. And you have to think that there could be no more than begin in your client data table, because there is no more user in the world than begin count. Begin could count 60% of the atoms in the C. So it's a very big number. So after doing that, you could just pick it as primary key, and as before, since it's a number, choose as identity. That's it. And then give a client ID. Oh, sorry, so I did a mistake here. So a client should be referred by an invoice ID. So invoice, you could think of that you have a billion cell in month or year, so you should go for begin. But if you have more than that, you should go for unique identifier. As I've said, that begin could count 60% of the atoms in the C, so it's a very big number. So if you have more invoice, if you think that you could have more invoices than that, you could go for unique identifier. You cannot outrun this because it's always different across time and space. Once it's generated, it will never be same. So it really depends on you, but rather than a unique identifier, numbers really have better performance. And also unique identifier have better performance than a varchar, but still, if you can put a data type in numbers, do it. It's very optimized and very have better performance in terms of scalable applications. So let's say for simplicity, I'm choosing big int, and same as I'm just putting it as identity. So you go to is identity and true. That's it. And as I have said that a client should be referred by an invoice. So you should put the client here. That's it. A client should have a client name. You could think of that first name, last name. So varchar, maybe 50. But if you have something more than 50, you should put it. But for our case, we'll just assume that it's 50. But some cases, the numbers for first names are very less, and you could think of as 30. But whatever you keep, the first name should be consistent everywhere. Maybe in the employee table, maybe in the client table. Every one of those should be same. So first name, last name, varchar. Last name could be bigger, so we are keeping it as 60, and that's it. Well, about the address, we're saying the address should be in different table uh, for both client and employees. So you can still take begin that because you cannot outrun begin for users. So that's it. And address ID. So this address ID should be here, and they should be linked. Yes, and address, let's say varchar, let's say 100. I'm keeping this address as in a different table, and it was in the question because the addresses are very huge. As you can see that it's varchar 100. So when you're searching, most of the time you're searching against the first name, last name, or the ID itself for getting the client information. The address is not really very effective every time you search. So that's why I'm keeping the address in different table. That's why the question says to keep it in different tables. But you could also merge those if you want. But since one client should have at least one address, not more than one, but it seems like that they have one-to-n relationship, but we could give a constraint to have the relationship as only one. So how can we do it? We can do it by indexes and keys. In the indexes and keys, you should add new index with the name, address, and you should have only one address at a time. That's when you say unique. That's it. You have the identity, and if you save it, you'll see that it's one-to-one relationship. So now, address should have country. Country should be not the varchar. It should be a ID from a different table. So country ID. Country should be small n. As you can see that a country couldn't overrun 32,000, but it could overrun 127 or 255 because as far as I remember, in the world we have 360 countries or maybe more than that. I don't know the exact number. Don't laugh at me, but it should be small int. Okay, so I missed that. So put it there. So you should have country display. That's a varchar. It's maybe that's 80. That's it. And a country should be linked with this. So here I made a mistake. Maybe it should be small int. Okay, so it's fine. Then you should have state ID. It should also be small int. If you think about logically, it should be also small int, and you should have a state table, and it should be small. I'm sorry, don't pick up, then put it there. Okay, so data types don't match. Okay, so it is not a primary key yet, so save it. Okay, so state display for char say 670, or maybe put AD just to be consistent. Okay, so here we have our address table, and you could have other informations like uh, house house long. It could be int, or it could be varchar. Maybe 5 varchar, just have the number, because house long sometimes have 2-5 3/8, something like that. And it could have room long. Maybe it could also be varchar. But if you could have in your business requirements, if you could have numbers, put in numbers, it's very optimized. And let's say it's also 5, and house, room, let's say street. Even though all of those are put it in there, but these are the specific information. If you are doing a search, like if BI search, these informations will be very helpful. You could get it from the address, but these separate informations are very useful for the address to specify where they are based on some custom queries. So could give those as different informations, or you could just remove that address and merge those in the runtime. That would be a much better solution. And that's it. So we have missed many of those, like we haven't draw the product details. So do it very quick. A product should have a timestamp that dated, that when it is selling. In most cases, you should choose, if you have date time, choose small date time. Don't choose date time. Date time has a very precise number of points. In most cases, you don't need that precise number of points. You just need the second. And date time have the milliseconds. And we have another data type called date time 2. Date time 2 in SQL Server, which is very much precise, which could go in very fraction of seconds. So if you want that precise, you should choose date time 2. But if you don't want that, if you want to save some space, choose a small date time. And I prefer that, because most of the time events don't need that fractions of time. So think about that. You could name it as, maybe dated is fine for me. So you could give the automated date as a default by giving the SQL Server function get date, which will give you automated default current date when you're generating this. And it should have product details. So we should have a product details table. Sorry, order details. Order details. So don't put your table name as S, because we haven't did any one of those with S. So try to be consistent. So it's a wrong name. I'm just going to delete it. Make a new table. Order detail. And I'm consistent with my names. I'm using the upper camel case. So that's it. ID and orders. We could have, let's say, big int of orders for our simplicity. And if you have, let's say, a bigger business where you have millions of billions of sales in every month or every year, you should go for unique identifier. But if BigInt satisfies your need, remember BigInt could calculate 60% of the 60 or 70 or maybe 80% of the atoms in the C. So it's a very big number. So if you are outrunning the BigInt, you should go for unique identifier. This decision should be made on the designing surface of the database, because you cannot do it after running your business, let's say for 5 years or 6 years. You can do that. You can do that, but it will be very time consuming. You have to do many of the manual things, and which will be very devastating. And some cases you have to change your programming for that. If you change the number to unique identifier, you have to change many things in programming. So think about that. If it is int to begin, still, if you're using ORM model, your all the int should be changed to long. So still, you have to change your data types. So you have to think about this when you're designing databases. So let's go very quick. Order details also have the information of product, that which product we're selling. So our product is represented by begin, as far as I remember. So it's the product. So it's putting it here, seeing that two names are same, giving the relationship, and it should have the buying and selling price, because if you think about it, a product, whatever price they have right now, could be changed 6 months from now. But it really doesn't mean whatever sold 6 months ago should be changed as well. You should keep the buying and selling price to individual items from your product table, which is not optimized, but you should keep it. Selling price, and this should be decimal, and we're keeping it 4 decimal places. That's it. So that's it. You really don't need more information than that. So you need to have invoice linked with this order. So just do it. Yes, your invoice is now linked with order. One-to-end relationship, country relationship, and data, client information. So we could optimize our scenarios for every invoice by giving a total value. And in database concepts, it's highly recommended that you shouldn't keep a column like total in invoice, because it's really uh, destroys all the consistency. But if you really think about it, you will never take an entry of total from user input. You will always take the input from programmatic system. So it will be always consistent. You don't have to rely on users. You can keep a total here, which will optimize your database in the long run. So whenever you need to calculate a total, you have to sum all those up. Maybe invoice have 10 items that they have sold. To each time to get the total, you have to sum all those 10 items. But if you have a total, when you're generating an invoice, if you keep that total in here, it will be very helpful. You could get it just by searching a one line of query, rather than summing up and giving aggregate function to the database, which will be much more optimized. So think about optimization as well. So it should be also decimal in 4 precise points. So let's say I'm total buying price. So to check that if I have any loss or not, total buying price, total selling price. So yeah, you could have discounts, decimal 4 digits. Okay, so that's it. We haven't designed the employee table, and we don't need to, because you have the idea that how can you do it. So it could be your assignment. You could try it out. And if you have any questions, email me, alim at, let me give you my email, alim at developersorganism.com. So stay safe, happy coding, design database efficiently, think through, and you'll be fine. That's it. Thank you.